Let's go on with two more examples of trig identities. This is one where it's I'm a real stickler about the backward logic thing, but even here I could admit the temptation to just cross multiply this thing, but that's really not legal logic, and it can get you in real trouble, especially later on if you do stuff that's more subtle. So let's look at one side or the other. It's a little hard to tell which was more complicated, but notice that on the right hand side it's a sum in a denominator. On the left hand side it's in a numerator. So I'd say the right hand side is probably more tricky. And so let's go ahead and start with that. Okay. And we're going to move it over to the left. Okay. Now this is one of those things where there is a very nice technique that we want to remember. I think we saw it in class, which is to, actually let me just copy that in again, multiply top and bottom by what we call the conjugate. That's an alpha, by the way. That's not an A or some sort of weird squiggle. That's an alpha, Greek alpha. Okay. And this is very much like rationalizing the denominator in an expression with roots, and it works in exactly the same way. We're not going to worry too much about the top here, but we're going to put the bottom together, and the miracle here is, hey, that's actually simpler than it looks. 1 minus cosine squared is really a nice, simple thing. And we're almost done here, suddenly, because this is going to be sine squared on the bottom. And that's, oh, sorry, I've canceled out the sine alpha before I was ready, anticipating that cancellation. So that's sine squared on the bottom, and then the sine and the sine squared cancels down to be, let me just copy and paste that thing. The sine alpha on the top goes away, and the sine alpha, one of the sine alphas on the bottom is stays there. And I want a guest voice to come up here. Does anybody want to be a guest voice? Me. Okay. Okay, so let's see. Can you say 1 minus cosine alpha?
1 minus cosine alpha.
Over sine alpha.
Over sine alpha.
Excellent, excellent. Can you confirm that answer? Can you say 1 minus cosine alpha?
1 minus cosine alpha.
Over sine alpha?
Over sine alpha.
Excellent. My assistants agree with me that we're done. Nicely done. Thanks, guys. You can go back to playing now. Okay, so now one more, and then we'll be done. One more identity. This is another one where multiplying by the conjugate is really useful. Again, if you could cheat and do it backwards logic, it'd be tempting to just kind of cross multiply, and it would be faster, but it would be wrong. And that's not good. Fast and wrong is not such a good thing. So I'm going to start on the right-hand side because it looks more complicated. It's a quotient. And I'm just going to go ahead and multiply by the conjugate. What's the conjugate here? Well, it's just the thing with the minus, with one of the signs changed. And so, remember, I can't just multiply by secant v minus tan v, for example, or that just on the bottom, for example. I have to always, if I'm multiplying something in, it has to be just 1. Top and bottom has to be the same, so I'm really just secretly multiplying by 1. What is this going to get me? Well, the top doesn't look particularly simple, although, gosh, it does look similar to what I'm trying to get, which is you can always look ahead. You can always look ahead to that and see what's going on. And then on the bottom, it's, again, the difference of squares. A plus b, a minus b is a squared minus b squared. And that's one where we have to remember, hey, that's one of the forms of the identities. 1 plus tan squared is secant squared. And if you manipulate that a little bit, you discover that secant squared minus tan squared is just 1. And so that's just secant v minus tan v over 1. And so voila. The right-hand side has gone through the chain of definitely true equalities to the left-hand side. And maybe my assistants can confirm this again. You want to confirm this again, guys? Okay. No, delegates first this time. Can you say secant v minus tan v?
Secant v minus tan v.
Alrighty, you want to say that too?
Secant v minus tan v.
Excellent. I think we all agree. Then we're done.